Hi everyone. Today we are going to be talking about solving quadratic equations using what's called the quadratic formula. Go ahead, grab a piece of paper, and let's get started. We're going to use the quadratic equation when we have an equation in standard form, so that's ax squared plus bx plus c is equal to 0. And we're trying to determine the zeros, the x-intercepts, or the roots. In other words, we're trying to solve the equation. And so we're going to use this formula called the quadratic formula. So the quadratic formula is, so I'm going to write it down here. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Where a is in front of the x squared, b is in front of the x, and c is the constant at the end. There is actually a little song or a little jingle that will help you remember the quadratic formula. So if you think of the tune Pop Goes the Weasel and you say the formula, it will help you remember. So it goes a little something like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's look at our first example. So we're going to solve the equation 2x squared plus 2x subtract 12 equals 0. So my a is 2, b is also 2, and c is negative 12. Okay, we're going to go ahead and plug it into our formula. So let's go ahead and write down our formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So x is equal to negative 2 plus or minus 2 squared minus 4 times 2 times negative 12. All over 2 times 2. Okay, we're going to go ahead and simplify. So simplifying, we have negative 2 plus or minus the square root of 4, and then negative 4 times 2 times negative 12 will give us positive 96 divided by 4. So this will give us x is equal to negative 2 plus or minus the square root of 100 divided by 4. So x is equal to negative 2 plus or minus 10 over 4. And here's where we're going to get the two zeros. So x is equal to negative 2 plus 10 divided by 4. And x is equal to negative 2 minus 10 over 4. And simplifying, so x is equal to negative 2 plus 10 is 8 over 4, which is 2. And negative 2 minus 10 is negative 12. Negative 12 divided by 4 is negative 3. So in conclusion, 2, 0, and negative 3, 0 are the roots, the zeros, or the x-intercepts, whatever you like to call them. Okay, let's go over to Desmos and see if these are in fact zeros. So I've keyed in the equation, and negative 3, 0 and 2, 0 are in fact our roots, or zeros, or x-intercepts, whatever you'd like to call it. Okay, next example. 2x squared minus 3x subtract 5 is equal to 0. So 2 is the a, negative 3 is the b, and negative 5 is the c. Okay, so let's go ahead and substitute it into our formula. So just be careful here. So because our formula has a negative b and our b is negative, so two negatives will make a positive. So this will actually be 3 plus or minus the square root of negative 3. Make sure your negative 3 is in a bracket, squared, minus 4 times 2 times negative 5. All over 2 times 2. Please don't forget to divide by 2a. That is one of the most common mistakes that is made. Students forget to divide by the 2a. Okay, let's keep going here. So x is equal to 3 plus or minus the square root of 9. So I have negative 4 times 2 times negative 5, which will give me positive 40 divided by 4. So x is equal to 3 plus or minus the square root of 49 over 4. So simplifying further, x is equal to 3 plus or minus square root of 49 is 7 divided by 4. So x is equal to 3 plus 7 over 4. And x is also equal to 3 minus 7 over 4. So x is equal to 10 over 4. And x is equal to negative 4 over 4. So x is equal to 5 over 2. And x is equal to negative 1. So as a coordinate, we have 5 halves, comma 0, and negative 1, 0. Okay, let's head over to Desmos. Okay, so typing in the equation, if I click on my zeros, I have negative 1, 0, and 2.5, 0. So 5 halves is the same as 2.5, so I know that these are in fact the correct zeros that we have calculated. Okay, let's look at our last example. So this time the A is 1, B is 4, and C is 3. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So x is equal to negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 3 all over 2 times 1. Okay, let's go ahead and simplify. So we have 4 squared is 16 minus 4 times 1 times 3, which is 12, all over 2. So x is equal to negative 4 plus or minus the square root of 4 over 2. So x is equal to negative 4 plus or minus 2 over 2. So x is equal to negative 4 plus 2 over 2. And x is equal to negative 4 minus 2 over 2. So x is equal to negative 2 over 2 and negative 6 over 2. So x is equal to negative 1 and negative 3. As a coordinate, negative 1, 0 and negative 3, 0. Okay, let's head over to Desmos and check. Okay, so taking a look at Desmos, we have negative 3, 0 and negative 1, 0. So those are, in fact, the zeros. So far we know how to factor to get the zeros, and we can use the quadratic equation to get the zeros. The quadratic equation for getting zeros is very effective when we have decimals. So it's not easy to factor when we have fractions or decimals. So when that occurs, this is when we're going to use the quadratic equation, or when we're looking at an example that is not factorable. Okay, that's it for today. Thank you for your attention. Bye-bye.